Calculating the electrical load for space heaters involves several steps to ensure safety and compliance with electrical codes. Firstly, we need to determine the total load. Given for space heaters, each rated at 7.5 kilowatts, the total load is calculated by multiplying the number of heaters by the power rating of each heater. So 4 times 7.5 kilowatts equals 30 kilowatts. To find the amperage, we use the formula amps equals load divided by voltage. In this case, the voltage is 208 volts, 3-phase. So amps per unit equals 30 kilowatts, or 30,000 watts, divided by 208 volts, which equals 144.23 amps. This is the total amperage for all 4 units. To find the amperage for 2 units, we multiply the amperage per unit by 2. So 2 times 144.23 amps equals 288.46 amps. Next, we address breaker sizing. Since fixed electric space heaters are considered continuous loads according to electrical codes such as Article 424.3b of the National Electrical Code, we must account for this continuous load by using 125% of the calculated load current. To determine the required breaker size, we multiply the load current by 1.25. So 1.25 times 288.46 amps equals 360.58 amps. Therefore, you would need breakers rated for at least 360.58 amps to handle the continuous load of these heaters. Moving on to conduit sizing, we must consider wire derating due to the number of current carrying conductors in the conduit. We will use table 310.16a1 as a reference. When multiple conductors are bundled in a conduit, the ampacity of each conductor must be reduced to prevent overheating. For 2 heaters with number 6 wire, we have a total of 7 wires. 3 current carrying conductors per heater, 1 ground, and 1 neutral if required, although the neutral may not be needed for a 208 volt 3-phase system. The ampacity of the number 6 wire must be derated to 70% of its original value. The spec sheet lists each heater's drawing 27 amps. Therefore, the total current for 2 heaters is 2 times 27 amps equals 54 amps, but we use the 27 amps per wire for the derating calculation. So, 7 wires times 27 amps equals 189 amps. Verify that number 6 wire, after 70% derating, can handle 189 amps. For 4 heaters with number 4 wire, we have a total of 13 wires. Again, 3 current carrying conductors per heater, 1 ground, and 1 neutral if required. The ampacity of the number 4 wire must also be derated to 70% of its original value. The total current for 4 heaters, using the 27 amps from the specification sheet, is 13 wires times 27 amps equals 351 amps. Verify that number 4 wire, after 70% derating, can handle 351 amps. Finally, voltage drop calculations are crucial to ensure that the voltage at the heaters is within acceptable limits for proper operation. Excessive voltage drop can cause the heaters to function inefficiently or even damage them. Voltage drop depends on several factors, including the length of the wire run, the wire gauge, and the current flowing through the wires. Without knowing the exact distance from the panel to the heaters and the type of wire being used, it is impossible to calculate the voltage drop accurately. However, it is strongly recommended to perform voltage drop calculations to ensure that the voltage at each heater remains within the acceptable range specified by the manufacturer and electrical codes. You can use online voltage drop calculators or consult with an electrical engineer to perform these calculations. In conclusion, the difference in amperage between your initial calculation of 20.83 amps and the specification sheet value of 27 amps is likely due to the fan portion of the space heaters. You would need breakers rated for approximately 360.58 amps to handle the continuous load of all 4 heaters. You can use number 6 wire for 2 heaters and 1 conduit and number 4 wire for all 4 heaters and 1 conduit, assuming that voltage drop calculations confirm that these wire sizes are adequate for the length of the run. Always consult local electrical codes and regulations and seek the advice of a qualified electrician to ensure a safe and compliant installation.